Good day, everybody, and you're welcome to another section of our online class. And in today's episode, we are going to be looking at exponential equation. The teacher that taught in the morning, she took enough time to explain what exponential equation means, how to identify them, and she also did the introductory section of it by bringing out the common practices attached to it. So I'm not going to go deep into it again and also start explaining what exponential equation is. So if you missed the first class, the morning section, she's going to drop a video on it, and I'll oblige you to please go back and read it or watch it before coming back to watch this. All right. I'm going to throw more light to it, and also I'm going to link our indices to exponential equation, because before ever you dive into exponential equation, you must have the basic and fundamental understanding of indices, how indices affect or correlate with our exponential equations. And in doing so, we must understand the laws of indices. First, we must understand the laws and how to apply them before we can go into learning exponential equations. So, without further ado, let's dive into it. All right. Indices. There are laws governing indices. Back then we were told that indices is the bedrock of all mathematics equation. If you want to be good in mathematics, you must have indices at the back of your hands, and you must be playing around with it. And of a truth, it is the basics of all mathematics expression. So, what are the laws of indices? The first law of indices is known as our addition law. In this addition law, we have the base, the power, multiply by another base and another power. The first thing you need to note here is the base are what? Equal. So pick one base. The powers are what? Different. So we do what? We have to add both powers. This is known as your addition law of what? Indices. That is the first one. The second law of indices is known as subtraction. In this subtraction, we have the base, the power, divide by another base, another power, equal to what? The first thing you note, check the two bases are what? The same. Pick one base, and then you do this, you subtract the powers. When you're dividing, you should be doing what? Subtracting. That is the next law of what? Indices. Then we'll move further to the third one, which is known as what? Zero law. Now, in this zero law simply implies anything, any number, any figure, any alphabet raised to the power of 0 is equal to what? 1. So even if it is 20 billion raised to the power of 0 is equal to what? 1. Whatever number that is raised to 0 is equal to what? 1. This is the third law of indices, which is known as your zero what law. The next one is known as your inverse law. Call it your inverse what law. Now in this inverse law, we have something like this. I'll have our base. Now the power comes with a negative sign. This is how we do it. You see this minus here? We convert it like this. Take the base, put it here. Whatever power you have here, put it up here. So in an event, we have something like this. It can be presented as this is 1 over a, my base, my power is what, n. I put it like this. So this is how we present our inverse law. The next on the list is known as your power what law. Power law. In this power law is where you have bracket open, the base, your first power, bracket close, your next power. This can be expressed as the base, the first power multiply by the next power outside. This is known as our power law. All right. The next one is known as our fractional law. Fractional law. In that fractional law is where you have something like this, the base, the powers are now dividing each other. The powers are in fraction. So how we express this is this. The base, the top power, bring it out, multiply by 1 over the power beneath. Do you get it? In that case, we have to put this in fraction, in bracket open, base, the first power. You close the brackets, then you put 1 over n outside. Or it can be of this form, a m multiplied by 1 over n power. In that case, I will now have to convert 1 over n, convert it to a square root of what? N. This is converted like this. Then I'll be having something like this, and then I have my base inside. Then I have my what? Power at the top. So if I'm having something like this, 2 raised to power 3. So what I should be having, I'll be having the cube root of what? A raised to the power of what? 2. That's what it is. So this is known as our fractional law of what? Indices. All right. Okay. So these are known as our laws of what? Indices. We must have the basic understanding and how to apply these laws before we can move into the aspect of exponential equation. So without further ado, I'm not going to waste more time on this. I will do 1 or 2 examples on this particular area, and then we move down to the main subjects, the main topic at hand, which is our exponential equation. So I'm going to do a simple question, and also I'll move to what? A complex question on it. Now, our first question is this. If we have, they said evaluate. Let's say we have something like this. 27 all over 8 into what? 1 over 3. solution. In order for us to solve this, what I normally advise my student to do first is, in every question there must be a clue. There must be a clue. It is left for you to unravel that clue for you to be able to solve the question. Now, when you see this question, you're seeing 3 outside. You're seeing 27 and 8 inside the bracket. The first thing you should do, check for any number that can divide 27 3 times without any remainder. Check for any number that can divide 8 3 times without any remainder. Why are we dividing it by 3? Because there is these 3 outside. That is the clue. So 27 can be divided by, you put 27 here, you put 2 here, 1, 2 into 7 is 3, remainder 1. So 2 cannot go. Change it. Let's try 3. 3 into 27 will give us 9. 3 into 9 will give us 3. And then 3 into 1 will give us what? 1. So in that case, 27 is the same thing as what? 3 raised to the power of 3. Same thing to what? 8. Let's try 2. We'll be having 4, 2, 2, 2, 1. So 8 is the same thing as what? 2 raised to power what? 3. Do you understand? So we have to put this in this particular expression for us to understand what we are doing. So I am going to change 27. Instead of me writing 27, I'm going to be putting 3 raised to power 3. And in place of 8, I'll be putting 2 raised to power what? 3. Mind you, I'm having 3 raised to the power of 3, 2 raised to the power of 3, all into what? 1 over what? 3. Now, this is similar to something like this, which is our power law. They are similar. So what we are going to do is that we are going to split them into 2. This is what I mean by splitting them into 2. 1 over 3, 2 whole number 3, 1 over 3. So we'll be having what? 3 times 1 over 3, 2, 3 times 1 over what? 3. So we'll be having 3 times 1 over 3, 2, 3 times 1 over 3. In this case, 3 here will go, 3 here will go, 3 here will go, 3 here will go. So we now have 3 raised to power 1 all over 2 raised to power what? 1. So 3 raised to power 1 will become what? 3. And 2 raised to power 1 will become what? 2. So this is your final answer. All the way from here, we ended up here, as in 2 over what? 3. Any question? All right. Now, that is our first simple question, our first simple equation. Sorry, let me go back to the beginning. All right, good. Now, our next expression will be the square root of 3 to x raised to power 4 y raised to power 2 all divided by what? 162 p6 z8. All right. Now, the first thing you need to note here is this. We have 32. We have 162. These are two large numbers. So how do we break them down? The square root here, this square root here is the same as 1 over 2 in form of a power. The square root is the same as 1 over 2 in form of a what? A power. What I mean is, if I have a square root of n, what I should be having is n raised to the power of what? Half. That is what it is. So take note. Take note. So what it means is, I can as well come here, put the whole of this. This becomes 32 x raised to power 4 y raised to the power 2 close bracket 1 over 2 all into what? 16 2 p6 and z8. So from here we try to break them down bit by what? Bit. The first thing we do, oops, sorry, let me put on my internet. Okay. All right. Okay. Let's see. Okay. All right. So here we are. The next thing we do is we need to break 32 to a smaller bit, and 162 to what? A smaller bit also. So the way we are going to do that is, we have to come down gradually on it. Sorry. Okay. We have to come down gradually on it. 32 and 162. Here we have 32. Here we have 162. So let's break it down. Let's see. 2 can go into 32 to give us 16. I'm dividing here by 2. I'm dividing here by 2. Why am I starting with 2? I want to break this down I want to bring it down to a smaller value which I can work with. I'm going to start with 2. If 2 does not give me any smaller value, I move over to what? 3. But for now, I'm starting with 2. Now, after dividing this, I have 16. Divide this, I'll have 81. So now I have 2 smaller values which I can work with. And now 16 and 81 are known as perfect square numbers. 16 and 81, I repeat, are known as perfect square numbers. Why are they called perfect square numbers? Because 4 raised to the power 2 will give me 16, and 9 raised to the power of 2 will give me 81. So these are two perfect square numbers. So I can now put them in this equation. Now I can successfully put them in this equation. All right, which in place of 32 x raised to the power 4 y raised to the power of 2 all over 162 p raised to the power of 6 and z raised to the power of 8. So in place of 32, after doing all the processes, I can as well put it as what? 4 raised to the power of 2. I will replace this with 4 raised to the power x, replace this as y raised to the power 2. Same, bring them same. Then in place of 162, I'm going to put 9 raised to the power of 2. This I'll put what? P raised to the power of what? 6. And this I'm going to put z raised to the power of what? 8. So the only thing I did is I changed 32 to 4 raised to the power of 2, changed 162 to 9 raised to the power of what? 2. Because I did my first division. All right. Now, take notes. All this is all over 1 over 2. Take notes. Now, this can be likened to my power law. So what it means is I'm going to come in now 4 raised to the power of 2, x raised to the power of 4, y raised to the power of 2, 9 raised to the power of 2, p raised to the power of 6, z raised to the power of what? 8. All 1 over what? 2. So this becomes 4 2 times 1 over 2 x. Sorry, let me reduce my font a bit. Sorry. Okay, good. Now I have what? 4 raised to the power of 2 multiplied by 1 over 2 x raised to the power of 4 multiplied by 1 over 2 y raised to the power of 2 multiplied by 1 over 2, all divided by 9 raised to the power of 2 times 1 over 2. Just the same way we did the first one, but in this case a little bit complex. Now I have what? P raised to the power of 6 times 1 over 2, and then I have z raised to the power of 8 times 1 over 2 times 1 over 2. So in this case I'll be having excuse me. In this case, I'll be having what? 4 into 1, because I'll be having 2 over 2. X, I'll be having 4 over 2. Y, I'll be having 2 over 2. All into 9, 2 over 2. P, 6 over 2. Z, 8 over 2. Since I'm multiplying them all, I'll be having 4 raised to the power of 1, x raised to the power of 2, y raised to the power of 1, divided by 9 raised to the power of 1, p raised to the power of 3, and z raised to the power of what? 4. Z raised to the power of what? 4. Now, in case you're wondering, 2 into 2 will give me 1. 2 into 4 will give me 2. 2 into 2 will give me 1. 2 into 2 will give me 1. 2 into 6 will give me 3. And 2 into 4 will give me what? 8. In case you're wondering where I'm getting the 2, 1 from. All right. So at this point, our final answer becomes 4. 4 raised to the power 1 is 4. We will now have x squared. Y raised to the power of 1 is y. 9 raised to the power of 1 is 9. P raised to the power of what? 3. And what? Z raised to the power of what? 4. This is now our final answer. This becomes our final answer. So this is the two simple and complex question that has to do with indices. So right now we are going to dive into exponential equation. Let's see how we can connect what we have learned in our indices up to our exponential equation. Now, example 1 in the exponential equation. But mind you, I want you to understand that exponential equation can also lead to quadratic equation. I want you to know that exponential equation can also lead to quadratic equation, and also exponential equation can also lead to simultaneous equation. It all depends on how the question is coming like, because sometimes your exponential equation will lead you to quadratic equation, sometimes it will lead you to simultaneous equation. All right, so the first example in our exponential equation will be this. I will dive straight down to the complex ones so we know how to handle it. The first one is 9 raised to the power of 2x plus 1 is equal 81 x minus 2 all 3x. Now, this is our first question. There is always a clue. There is always a clue when a question is given. In this instance, the clue here is this. Look at 9, look at 81, and then look at 3. You understand with me that there is a common link between those three bases, and the common link is that 3 can divide 9, 3 can also divide 81, and 3 can also divide 3. That is the common link. So 9 will be what? 3 raised to the power of 2. 81 will be what? 3 raised to the power of 4. And 3 will be what? 3 raised to the power of what? 1. This is the first thing you need to note. Then the next thing that comes in place is replacing this 9 here with 3 to the power of 2 all into 2. 3 to the power of 2 all into what? 2x plus 1 is equal to, replace this, replace this 9 to be what? Replace this 9 to be what? 3 to the power of 2, 2x plus 1 equal to, replace this 81 to 3 to the power of 4 into x minus 2, and then replace this to be what? 3, 1x. Remember, we are dealing with what? Indices as regards to what? Exponential. Remember when we had this law? Remember when we had something like this? M divided by n. we ended up having it as a. We ended up as having it as a m. We ended up having it as am minus n. We ended up as having it as am minus n. So in this case, we have what? 3 4x minus 2 all over what? 3 1x. So this becomes the two bases what? The same. So we pick one of the base. 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 And then this become 4. We pick one of the what? Base. This becomes what? 4 into x minus 2. And then this goes up, become what? Minus 1x. Becomes what? Minus 1x. So what we are having now is this. This becomes 3 2 into what? 2 x minus 1 is equal to what? 3 2x minus 2 minus 1x. Sorry, it's not really coming out. Minus 1x here. Minus 1x. So in this case, check. We have 3 on the left hand, 3 as a base on the left hand side, and we also have 3 as a base on the right hand side. So both 3's will go. Both of these 3 will go since they are what? Equal. So you remove this 3 and then you remove this 3 since they are both what? Equal. Then you'll be left with just what? The base, the powers, which becomes 2, which becomes 2 into 2x minus 1 is equal to what? 2 into x minus 2 minus 1. This becomes 4x minus 4 is equal to 2x minus 4 minus x. No, sorry, please, sorry. I made a mistake. Oh, sorry, I've made a mistake. Okay, please, this is 4. It's not 2, it's 4. Here is 4, please. Here is 4. Okay, thank you. So since the two bases are the same, we remove them. We'll be having 2 into 2x minus 1 is equal to 4 into x minus 2 minus 1x. Thank you. So this becomes, we open the brackets, this becomes 4x minus 2 is equals to 4x minus 8 minus 1x. This becomes 4x minus 2. 4x minus 1x becomes 3x minus 8. Is this a plus? No, this is a plus. This is another plus. This is a plus, and then this is another plus. Sorry. And then this is another plus. Sorry. Okay. So we do what? We collect like terms. Now, collection of like terms will mean we'll be having 4x here. We move this 3x to the other side, it becomes minus 3x is equal to, we have minus 8 left here, and then plus 2 crosses over to that side, becomes minus 2. So 4x minus x will become x, we'll have minus what? 10. So this becomes our final answer. This becomes our final answer, where x is equals to what? Minus 10. All right, one more exercise on it. Sorry, I made some few mistakes with my numbers there. Sorry. Right, I'll try and this time and be calculated. All right, the next one is simplify. Simplify 4 raised to power all of divided by 27 is equal to what? 3 all over 4 t minus 1 power. Solution. Like what I normally say, they will give you a clue to every question. Now, what they are trying to make you to understand with this particular question is this.